All right. Looks like we're going to be doing Algebra 2 Lecture 922 and 923 today. State Standard OAS A2A14. And our objective, the student will solve quadratic equations. Quadratic means that the highest power of our variable is a 2. Quadratic equations, so there will be an equal sign in there, by factoring and employing the zero product property. So I want to talk about, we've been working on factoring for the last couple of weeks, so we're going to factor today, something you already know how to do, and we're going to employ the zero product property, which is something we have not talked about, but we're about to. So here's how the zero product property works. The zero product property says that if you have any two things that are multiplied together, I just called them A and B, we can call them anything we want, X and Y, whatever. But if we have two things that are multiplied together and we get 0, then either the first one has got to be 0 or the second one has got to be 0. So if you multiply two things together and you get 0, one of these has got to be 0. That's the zero product property. We're going to use that and we're going to factor. The factors will be set equal to 0, and then we'll say, well, either this one or this one has got to be 0, and we'll solve. That's how we solve. One way we solve quadratic equations. So let's take a look at this. Factoring. Now these right here are factors. Things that are multiplied together are factors. Factors multiplied together equal 0. One of the factors has got to equal 0, and that's what we're going to be doing here. This is solved by factoring. And I've got quadratic equations here with equal signs, so they're equations. What we want to do is make sure that one of the sides is equal to 0, and then we're going to factor it. So I look at this one. I say, well, I could turn this side into 0 very easily by just subtracting 3. This side is now 0. But I have to subtract 3 from the other side just to stay in balance, just like we did back in pre-algebra. And we rewrite b squared minus 4b minus 12, because these are the same signs, so we add and keep the sign, is equal to 0. Now we've got a quadratic equation equal to 0, and we want to employ the zero product property. In order to do that, we have to factor this, because the zero product property says two factors that equal 0 means that if they're being multiplied together, two factors equaling 0, one of the factors has got to be 0. So I've got to factor this. This is equal to 0, and once I factor it, I'll have the zero product property that I can use. Take the square root of this one, put it here and here. I'm looking for factors of 12 that will add up to or subtract to give me a 4. And 2 and 6 will work. 2 times 6 is 12. And 6 minus 2 is 4. It doesn't matter where I put the 2 and the 6. What matters is that they have to add together to give me negative 4. So I say, in order for that to happen, 6 has got to be negative and 2 has got to be positive. Now I'm ready to employ the zero product property. I've got a factor times a factor is equal to 0. One of these has to be 0. So it's either this one, b plus 2 is 0, or b minus 6 is 0. It's supposed to be a 6. There we go. And then we have really simple little pre-algebra type problems right here that we solve, and we'll wind up with two separate answers that will make that quadratic equation true. Subtracting 2 from both sides yields b is equal to negative 2. I subtracted 2 and I subtracted 2. And here I would add 6 to both sides. I'll go ahead and show that just in case you need to see it. Adding 6 to both sides yields b is equal to, this is 0, and this is 6. Those are our two responses. I'll go ahead and show subtracting 2 over here also. We subtract 2 from both sides. b plus 0 is b, and 0 minus 2 is negative 2. These are the two values that I can plug into this original equation that will make this true. If I plug in a negative 2 right here and do this arithmetic, I'll get 3. If I plug in a 6 right here and do this arithmetic, I'll get 3. So we solve this quadratic equation by setting the equation equal to 0, factoring it, and employing the zero product property. If this times this is 0, then either this first factor is 0 and we solved, or this second factor is 0, and we solved. Two solutions, they're often listed in set notation, -2, 6. And again, the order of the answers doesn't matter. I like to put the smallest one first, but it's not necessary. You could list it like this. Either one of these would be appropriate. Okay? And let me see if I have the answer sheet, see if I got it right. 6 and -2 is what it says, and that's what we got. Yay! Set whose members are 6 and -2. Those are the values that will make that true. Let's do another one. I've got this quadratic equation. I want to set it equal to 0, so I'm going to add 4 to both sides. This will give me x squared minus 3x minus 18 is equal to 0. -22 plus 4 is 18 because they're different signs, so I subtracted and I kept the sign of the one with the greater absolute value. 4 minus 4, of course, is 0. Now I'm going to factor this and employ the zero product property. Square root of this one here and here because my leading coefficient's a 1. Looking for factors of 18 that add up to 3. Well, 2 times 9 won't work. 3 times 6 will work. 3 times 6 is 18. 3 times 6 is 18, and 6 minus 3 is 3. And I want it to add up to or subtract and give me -3. And the only way that can happen is if the 6 is negative and the 3 is positive. So I have the quantity x plus 3 times the quantity x minus 6 is equal to 0. That means either x plus 3 is 0 or x minus 6 is 0. And we solve. I subtract 3 to get rid of that. I do that on both sides. Gives me x is -3. That's one of my solutions. We add 6 to both sides here to solve this, and we get x is equal to positive 6. Those are our two solutions. If I plug in -3 right here and perform those operations, I'll get -4. If I plug in a 6 right here and perform those operations, I'll get -4. And as I said, they're often written in set notation. You might see them written like this on the ACT, and the order of the solutions doesn't matter. It doesn't matter which one comes first in our set notation. Okay, this is just the set of the answers. It's not an ordered pair. It's just the set of the numbers that will make that true. Okay, does that make sense? Let's see if I have any more. I do. So here we go. I want to solve this quadratic equation. The variable's a k this time. That doesn't matter. I'm going to set this side equal to 0. So I'll add 6. Rewrite my equation. Yields k squared plus 2k. -30 plus 6 is -24. They're different signs, so I subtracted and kept the sign of the one with the greater absolute value. It is equal to 0. So now I'm ready to factor this and employ the zero product property. Square root of this one here and here because my leading coefficient is a 1, as we've talked about in the past. Factors of 24 that add up to 2 would be 6 and 4. 6 times 4 is 24, 6 minus 4 is 2. I want it to add or subtract to give me a positive 2. And the only way that can happen is if the 6 is positive and the 4 is negative. And now I employ the zero product property. I say, if this times this is 0, then either this has to be 0 or this has to be 0. And I solve both of these little equations. Subtracting 6 from both sides yields k is equal to -6. Adding 4 to both sides, we undo, so to speak, what's done to the letter. We add 4 to both sides. We can do this in our heads. You don't have to show it. K is equal to 4. So here are our two solutions. I'll plug in -6 here and here. This will be 0. Or I could plug in a 4 right here and here, do the arithmetic, and this would be, -6, not 0. And I could write the answers like this. The set whose members are -6 and 4. And it doesn't matter which element of the set comes first. Could be written like this, or like this, or like this. Okay. All right, last one, let's take a look at it. I've got a quadratic, meaning the highest power of the variable is 2, equation. I'm going to set it equal to 0 by subtracting 5 from both sides. This will yield x squared plus 3x. These are the same signs, so I'm going to add them together and keep the sign. And these are different signs, so I subtract and that yields 0, which is what I want. Now I'm going to factor this and employ the zero product property. You can see that my leading coefficients are 1, so I can just take the square root of x squared and put it here and here. Looking for factors of 18 that add up to 3, that would be 6 and 3 again. We had that earlier, 6 and 3. I wonder if that's the same equation. I don't think it is. I want them to add up to positive 3. Different equation, but has same solutions. How about that? In order for these to add up to positive 3, the 6 has got to be positive, the 3 has got to be negative, and now I employ the zero product property. If this times this is 0, then either this one is 0, x plus 6 is 0, or this one is 0, x minus 3 is 0. And we solve both of these little equations. Subtracting 6 from both sides yields x is equal to negative 6. Adding 3 to both sides to get this, to isolate this x here, yields x is equal to positive 3. Those are our solutions, and you will often see them written in set notation. And again, it doesn't matter which element of the set comes first. Those are our solutions. Those are our solutions, meaning that if I plug in negative 6 in here and here, do the arithmetic, I'll get 5. If I plug positive 3 in here and here and do the arithmetic, I'll get 5. Okay. And now I got to check to see if I got those right. 4 negative 6 and 3 negative 6. Yay! So there we go. That's solving quadratic equations by factoring. And the key is to set your quadratic equation equal to 0. Do whatever you have to do to make one side equal to 0. Then we factor, and then we employ the zero product property. If this times this is 0, then either this one has to be 0 or this one has to be 0, and we solve those little equations, and we're looking at our answers. You can do this.